Ladies and gentlemen, this is Mr. Green, and this is another in my series of geometry videos to help you with the geometry course. So, where should you be in my course? At this point in the course, you should have just finished the Unit 3 Part 1 and Part 2 test, or be working on them to get them turned into me pretty quickly, because we are starting Unit 4, and I don't want you to get falling behind in what we're doing, okay? So, at this point, be looking at that Unit 4 stuff, complete all that Unit 3 stuff. Don't forget, I do allow you to make corrections in my course, and that means any item in my course that is computer graded can be corrected. That means all the quizzes and the unit 1 part 1s and the unit part 1s and the mid unit exams, all of those can be corrected. All you have to do is click on the grade in the grade book and copy and paste the questions over to a Word document, and then show me how the work is done correctly. Don't just copy and paste it and leave it there. Don't just tell me the answer should be A. I really want you to show me how the work should have been done correctly. Don't worry about any images or anything like that. I know what the pictures look like. I've seen them a few times, so not worried about that. After 28 days with a 0, the grade gets finalized, and that means it would stay at a 0. So you want to make certain you get these things made up. If you're missing something, do not let them be a 0. That is the worst thing you can do to your grade, is let it be a 0. Okay? Okay. Let's talk about congruence. We have studied a couple things that have related to congruence. We've studied a couple of properties that allow us to say if two things are congruent, then there's some things we can do, but we've never really talked about what is congruent. So if we're talking about polygons, polygons are simply multi-sided objects. Any type of multi-sided object, to be congruent, they have to be the same size and the same shape. They'd have to have the same number of angles, and they all be the same, and all the sides be the same length for it to be considered a congruent polygon. That's all it is. Congruent simply means the same. Same size, same shape. Okay? So that's all you got to remember about congruent polygons. Now, to make this easy for you, you see two polygons being congruent. You see this symbol in between here says that they are congruent. I want you to notice angle A, angle F, they are related to each other. They are the ones that are the same size. Angle C, angle H, they are related. They are the ones that are the same size. How do I know that? Because in the name itself, they are listed in the same order. So if they're congruent angles, they're going to be listed that way. By the same token, side AB, guess what it relates to? Side FG. So to answer this question over here, AB is going to be congruent to FG. That is the way the naming mechanism works. It allows us to name things in such a way that we can see which ones are related. So BC, which is the second two here, are going to be related to GH. That is simply taking them in order of that they are seen in the name. Okay? Well, the hardest one here is EA. It's the last one and the first one. Well, that means I'm going to use the last one here, J, and the first one, F. And that's going to be my congruent side to EA. So just by looking at the name, not knowing anything else about the polygons, I don't even have to see what the polygons look like. If I just have the name of the two congruent polygons and I'm told they're congruent, I can look at it and say, well, this side must be congruent to this side, and this angle must be congruent to this angle. That's how you can match up those names and those parts of the names to make things work out correctly, just like in the angle. So I just told you this. What does angle A relate to? It relates to angle F. How do I know that? Well, I know that because in the name, A is here and F is here. They're both the first ones in the name. So where does angle E fit? Angle E is the fifth one in that name, Angle J is the fifth one in this name, so this one would be angle J. How about angle H? Angle H is the third one over here. It's going to relate to the third one over here. That's going to be angle C. Do you see how this works? It becomes very easy if we just use that naming mechanism to make certain we've got things named correctly. If they're named correctly, then we can see what's congruent to each other. Okay, I want you to be absolutely sure you know how to name polygons. So here is a polygon. I'm not saying it's congruent to anything. Obviously, we can start with the letter A, B, I'm sorry, I'm not writing very well because I'm trying to use my mouse and it never works very well for me when I'm doing that. So let me whip out my pen real quickly here and finish this. C, D, E. And what did I do? I started at A and I went around it that way. Is there anything from stopping me from going around that way? Absolutely not. I could do that too. I could start at A, go to E, go to D, go to C, go to V. As long as I go all the way around in an order. Well, Mr. Green, could I start at B? Why, sure. B, C, D, E, A. And if I started at B, could I go the other way around? Why, sure. B, A, E, D, C. Can you see where it depends upon where I'm starting and which direction I'm going around the polygon. But as long as I go around the polygon, naming each one of the vertexes, it doesn't matter how I'm doing it. I'm just going to write the rest of them down here real quickly. C, D, E, A, B, and C, B, A, E, D, D, E, A, B, C, and D, C, B, A, E, and E, A, B, C, D, and E, D, C, B, A. Ta-da! 10 different ways to write the same polygon. So which one would be the right one if I had another polygon over here? It doesn't matter how you write the first one, as long as you write the second one with the corresponding, the angles that are congruent in the same order. So it becomes real simple to do. You just have to go around the polygons. Make certain you start at the same spots. Since the polygons are equal, it would be easy to find an equal angle to use there. So let me just give you the polygon congruence postulate. And remember, it's a postulate, so there's no proof on this one. It just is going to tell you that it does exist. Two polygons are congruent. Notice it says if and only if. That means it's a biconditional. It can work both ways. It is true going forward and backwards, right? So two polygons are congruent if and only if there is a correspondence between their sides and angles, so that all pairs of corresponding angles and are congruent, and all pairs of corresponding sides are congruent. Wow. So one way to prove polygons congruent would be to find all the angles and all the sides and make certain they match up between the two polygons. Lots of work. From the flip side, if I know that two polygons are congruent to each other, then we can say that all the angles and all the sides are congruent to each other. This has a name. It's corresponding parts of congruent polygons congruent. CP, saying that the corresponding parts of congruent polygons are congruent. That is the converse of this postulate, okay, which we can use, but that has a name. That one gets used all the time. Proving all the sides and all the angles congruent, that's a lot of work, and no one really wants to do all that work. So we will come up with ways of making this a little bit easier. Now I want you to notice here I've got two triangles, and these two triangles are stated to be congruent to each other. So if I'm looking for the congruent side to AB, I would be looking for DE. If I were looking for the congruent side to BC, I'd be looking for EC. If I was looking for the congruent side to AC, I'd be looking for DC. If I'm looking for the congruent side to DE, I'm looking for AB. If I'm looking for the congruent side to EC, I'm looking for BC. If I'm looking for the congruent side to EC, I'm looking for BC. That's written the same thing twice. Okay? That was kind of funny, but it worked. So what's the congruent angle to A? That would be angle D. What's the congruent angle to B? That'd be angle E. What's the congruent angle to C? Well, you know what? C is tricky because C is in this triangle and in this triangle. So I think they've just misnamed this one. What they really mean is what's the congruent angle to BCA? And in that case, I would say that it is angle ECD, because you want to go in the same order. Okay? D and B are congruent, and E and B are congruent. I'm sorry, D and A are congruent. Sorry, said that wrong. And E and B are congruent. And F, you know what? There is no F. There is no F to be congruent to anything there. Okay, having done this, what we're looking at is formulating conjectures about properties and attributes of polygons and their component parts based upon some exploration and some concrete models. What I've been doing is introducing the concept of congruence. Okay? We'll get more into congruence as we go through this unit, but I wanted to make certain I introduced it in a nice, easy format. Okay? Well, don't forget to tell me that you're in geometry and what your section number is when you send me K-mails, when you send me instant messages. It really helps me know who you are and find your records and help you get your information that you need a little bit better. Okay? So, it's been nice talking to you, and I will see you next time.